moving on to the next topic, which is work done against friction. Now we'll initiate it with a very simple example of a body moving on a horizontal surface, which is considered a horizontal surface like this, where we have a body of mass m. So the weight of the body will be vertically downwards, which will be equal to mg, and the normal reaction would be exactly equal to mg at this case, because the horizontal because it is moving in a horizontal direction. Now if I apply a force F on the body, then there will be a frictional force acting on the body in opposite direction as where the body is going to move. So this will be the direction of my frictional force, right? F. So we need to calculate the value of work done in moving this body from this point to, suppose, this point, covering a distance of s. The formula for work done is very simple, that is force into displacement. But what force? The net force acting on the body. Now in order to move this body in this direction, the applied force must be at least equal to the frictional force. It has to be greater than frictional force, obviously, but the last possible scenario is this force has to be at least equal to the frictional force, so the body starts moving. So this is the minimum value of force that must be acting on the body, so that the body will be moving in this direction. So work done would be what? Force into displacement. The force at this point would be equal to the frictional force acting on the body multiplied by the displacement. What is the formula for frictional force? That is mu into normal reaction R, mu R into S. Now this is equal to mu mg into S. So this is the value for work done on the body. Now very important thing, you might get numericals on similar situation where, let's take an example, okay. Let's take up the values of this, and I'll tell you why I'm doing this. Suppose the body is of mass 10 kg, where applied force is of 20 newtons, and the value of mu between the body and the horizontal surface is 0.1. Let's calculate the value of frictional force. Frictional force is mu r, which will be equal to mu mg, which is 0.1 into mass 10 into g. Let's take it 10 for now. So it should be 9.8, but right now, just to give you the exact what I'm going to explain, the idea, that's why I'm taking it 10, just for numerical easy sake. So this comes out to be 100 upon 10, which is 10 Newton. So the frictional force is 10 Newton and the applied force is 20 Newton, right? So the applied force is much greater than the frictional force. So this time net force acting on the body, this will be calculated by how? The applied force minus frictional force. This is what we are going to do. We are not going to take straight away 20 Newton to calculate the value of work done, because 20 Newton is not acting on the body. Out of 20 Newton, 10 Newton, which is in opposite direction, that is due to the frictional force, 10 Newton is acting in this direction, right? So this 10 Newton gets cancelled out of 20 Newton and you are left only with the last 10 Newtons. So you will have to do this, but in expression what we did, we calculated by using simply the value of force which has to be minimum applied on the body, that is equal to frictional force. Here we are doing something else. So keep this thing in mind. When you have to calculate the work done, don't go by formula, always go by the method, okay. The formula will give you this straight away mu mgs, and if I would have applied the same formula here, my answer would have been wrong, right? So here the net force is 10 newtons, that is 20 minus frictional force, applied minus opposing force. So for such cases, what you need to do, I am still asking you not to go directly by the formula. Instead, let's change the formula. This is the most general formula we find in books, but let's change the formula. What we are going to do, the net work done has to be calculated by net force multiplied by the displacement which is being done in the direction of force or opposite to the direction of force. Opposite means the negative work done by. So net force is applied force minus frictional force multiplied by displacement, and here it will become F minus mu mg, right? Frictional force is mu into r, mu into this r is mg. So this is the value of total work done. So if you have to learn the formula, learn this formula, and if you according to numerical change the circumstances, right? And I'll again ask you not to learn the formula, instead go by method, not by the formula. So this is the work done in case of body moving in horizontal direction. So let's take another example of a body which is moving up an inclined plane. So when there is an inclined plane and a body is placed on it, we'll have to exert some external force in order to keep the body moving upwards, because there will be a factor of gravitational force which will try to bring body downwards, right, along the inclined plane. So to do that, this is our inclined plane at an angle theta. Here the body is placed like this. Okay. First of all, the weight is always vertically downwards, which is mg. So the component of weight will be this and this, perpendicular to the plane and along the plane, that is horizontal to the plane. So this would be mg cos of theta and this is mg sin of theta. Now this is the component of force I was talking to you about, that this force is going to bring the body down. We have to calculate work done in taking the body up the inclined plane. So there must be some external force which will be acting on the body in this direction, right? But before that, if there is no work done, there is no external force acting on the body, that means the body is going to slide down. So let's calculate in the first case that the body is sliding down, so it will be the work done by the gravitational force, that is this factor of gravitational force. So this case, work done is, what would be the net force acting on the body? If this is the component which is taking body downwards, so this component of force is greater than the frictional force, that is why body is moving. If it would not have been the case, if these two forces are equal, the body would have remained stationary at this point. There won't be any sliding motion, right? So if the body is going downwards, that means this force is definitely greater than the frictional force. So the net force acting on the body is mg sin of theta minus frictional force. What is frictional force? Frictional force is mu r. And what is normal reaction? This is the normal reaction, which is this component mg cos of theta. So the final answer becomes, is this right, this whole equation? No, work done is net force into the displacement. Suppose this is the length of the inclined plane from where the body is to be taken. So this thing multiplied by length, mg sin of theta minus frictional force, which is mu mg cos of theta, that is mu r, right? So this force multiplied by L will give you the work done by the gravitational force in taking down the body inclined plane. Now in second case scenario, what we are doing, we are applying a force in upward direction to take the body up the inclined plane, like this, in this direction. This is the applied force. Okay. So when body is being applied by a greater force, this component is already acting downwards, but along with that, according to a direction of applied force, there will be another force of friction which will act in this direction, that is downward direction. So both of these forces sums up and they act opposite to the applied force. So in second case, the net work or the net force is the external force minus sum of two opposing forces, which are mg sin of theta minus frictional force, or this, first of all, this is the net force multiplied by the length of the path the body covers in the direction of net force. So this whole thing becomes m minus mg sin of theta minus frictional force is mu into r. The normal r reaction is mg cos theta, so this becomes mu mg cos of theta, right? This is the net force acting on the body, and since we have to calculate work done, multiplied by the path of the length, sorry, length of the path. So this is how we calculate. So again I'll repeat that you should not go by the formula, instead go by the method, which is very easy.